All right, to start things off, let's assume that you're given 3 numbers that represent the side lengths of a triangle. Your question is, 1. Will those 3 lengths make a triangle? Now, there's a couple of possibilities for what could happen. They could produce a triangle. That triangle might be acute. It might be right. It might be obtuse. But there are also some other options that are possible. For example, what if I'm given side lengths where it doesn't even make a triangle? What if it makes something like this, for example, where no matter how I spin and rotate those 2 sides, they just never intersect? Or there's the possibility that maybe they just make a straight segment. So I start and I lay down my longest side first, and then I lay down the shortest side, and the only place where these other 2 sides intersect happens to be a point on the segment itself, in which case all we've done is create some collinear points. Or the third possibility is you actually get some sort of triangle. Now, we've talked previously about how we answer that question, and we know that in any triangle, the sum of the lengths of any 2 sides has to be greater than the length of the third side. If that condition is satisfied, then I know I get a triangle. If that condition is not satisfied, then one of these 2 things is happening. Now let's consider the second question. The second question is, okay, now that I know it's a triangle, what type of triangle does it make? There, what we're trying to answer is the triangle acute? Is the triangle a right triangle? Or is it an obtuse triangle? So given any 3 side lengths, I have to answer these 2 questions. First, will it even make a triangle? If it's not going to make a triangle, then there's no sense trying to figure out what type of triangle it is. So if it makes a triangle, second question, what type? Now, to answer the second question involves a little bit more work, and it involves what's known as the converse of the Pythagorean theorem, and there are a couple other associated non-named theorems that we use in conjunction with it. So let's consider this first set of numbers. So in each of these, I'm going to give us a set of numbers that represent the side lengths of a triangle, and in our first case, we're looking at the numbers 5, 12, and 13. So, condition 1, does the sum of any 2 side lengths exceed, or is it greater than, the length of the third side? Now, what you really have to check in this case is, if you add the 2 smaller lengths together, which in this case are the 5 and the 12, is that greater than the length of the third side? If the answer to that is true, if it is yes, then we can go ahead and continue with determining if it's a triangle or not. So what we're answering here, will these lengths create a triangle? In the case of our first example here, 5 plus 12 is 17. 17 is greater than 13, so that's acceptable, which means yes, we could create a triangle with those 3 side lengths. Now let's look at another example, number 2. In number 2, we're looking at the numbers 7, 9, and 1. And we're going through the same process. So add the 2 smaller sides together. 1 plus 7, is that greater than 9? Now in this case, 1 plus 7 we all know to be 8. And 8 is clearly not greater than 9, so will this make a triangle? No. In fact, what this would create is a situation like this first one, where we see 2 segments that leave a gap, where they won't intersect one another at all. All right, so now that we've got the first question out of the way, or at least how we accomplish it, let's talk about how we go about answering that second question. Now, as I mentioned before, this involves something known as the converse of the Pythagorean theorem, and the 2 other unnamed theorems that go along with it. So, I'm going to kind of describe all three of these theorems together, but ultimately they go back to some same notation that we use with triangles in general. Okay, so let's assume we have a triangle, and for the sake of discussion, we're going to call that triangle ABC. A, B, C. Now, it is customary that the side opposite angle A is listed as a lowercase a, which would be here. The side opposite angle B would be a lowercase b, and the side opposite angle C would be a lowercase c. Now, there are three conditions that could be, one of which could be true if it creates a triangle in the first place. If c squared is equal to a squared plus b squared, we get a right triangle. And that's your converse of the Pythagorean theorem. We know in the Pythagorean theorem it states if a triangle is right, then a squared plus b squared is equal to c squared. So in this case, the converse is saying, well, if that equation is true, then the triangle has to be a right triangle. But there are some other possibilities as well. If c squared is less than a squared plus b squared, then we get an acute triangle. And you can probably guess what the other one will be. If c squared is greater than a squared plus b squared, then we get an obtuse triangle. Now, there's something important to note here, and this is highly important. C in these equations, or in these inequalities, is the largest side. It's the one that's longest. So whenever we start to substitute n values into these three inequalities or equation, then ultimately what we're going to do is make sure that we have the largest side in the place of C and the two other sides in place of A and B. Now, it may be that you have some side lengths given where two of the sides have the same length, in which case, as long as C is one of those largest sides, it'll work just fine. A and B have to be the lesser two. Now, so for example, let's say we have a triangle with sides 3, 8, and 8. Then the 8 is the largest number, so that would have to take the place of C, and the other 8 and the 3 take the place of A and B. But as long as C is the largest number in the three numbers that you're given, these expressions or inequalities are going to work out. So let's look at what we then get from some examples. So in each of these, I'm going to give you three values. And what we want to determine is it a triangle? In other words, will the three lengths that you're given create a triangle? And if so, what type of triangle? Okay, so we're going to use that first example that we looked at a moment ago, number 1, 5, 12, and 13. We've already identified that it does create a triangle, and once again, we know that it does because if we take the sum of the two smaller sides, that is greater than the largest side. So yes, it is a triangle. Now let's consider what type of triangle it is. So C in this case has to be this 13, which means A and B have to take on the values of 5 and 12. It does not matter which one's A and which one's B. So I want to compare then C squared to A squared plus B squared. And I'm not going to put a symbol there yet because I'm checking to see, are they equal? Is that going to be a less than, or is it going to be a greater than symbol? So we know C is 13, that longest side. So this becomes 13 squared, or 169. Now let's consider the other side. 5 squared plus 12 squared, which is 25 plus 144. Remember, order of operations says we take care of those exponents before we add. We add those two together and we get 169. Now, in this case, both expressions, the c squared and the a squared plus b squared, produce the same value. So we would say these are equal to each other. 169 is equal to 169. When that happens, it indicates that the triangle is right. So will it make a triangle? Yes. What type? Right triangle. All right, let's look at a second example. In number 2, here we're going to be given the values, the square root of 8, 4, and 6. Okay, so let's grab a little calculator for a moment, and we're going to figure out what decimal value the square root of 8 has. All right, so we type into our calculator the square root of 8. Okay, square root of 8 is approximately 2.8. Now, why do I need to know that? Because I need to identify which side is c, which one's the longest. I don't know the square root of 8 off the top of my head in decimal form. So if I look at the decimal form here, which is about 2.8, this one's 4 and this one's 6, then that tells me the 6 has to be the c value. So, first things first, check to see that it's going to make a triangle. This is our largest side, so will the square root of 8 plus 4 be greater than 6? Okay, so we've got the square root of 8 here. I know it's 2.8. If I add 4 to that, it's going to give me 6.8, etc. So will that be greater than 6? Yes. Okay, now that I know it's going to make a triangle, let's check and see what type. So we take the square root of 8 squared plus 4 squared, and we're going to compare that to 6 squared. Okay, when you square a square root, we know that those cancel each other out, in which case here we get 8 plus 4 squared, which is 16, and 8 plus 16 is 24. Now on the other side, 6 squared is 36. And I know from experience, as you all do, that 24 is less than 36. Now be cautious here, because the order in which we've written it might make it look reversed to you. Remember, you're comparing in each of these the value of c squared to the value of a squared plus b squared. So our c squared here is this 36. So what we see is that the c squared is greater than a squared plus b squared. This 36 is greater than the 24 that we got on the other side, which means in this case, we have a triangle that is obtuse. All right, let's look at one last example. Number 3. In number 3, we are using the square root of 13, 8, and 12. Okay, so there again, I want to figure out what the square root of 13 is, because I need to identify my longest side. So the square root of 13 is approximately 3.6. So this is 3.6-ish. 8, and 12, which means our c value in this problem is 12. Okay, so first things first, check to see if the two smaller ones are larger than the largest. So is the square root of 13 plus 8 greater than 12? In that case, if I take this 3.6 and I add 8 to it, I can see that I get a value that is not greater than 12. So this is no. Does it make a triangle? No, it's not a triangle. Now what does that mean in terms of the second question? What type of triangle does it make? It doesn't make a triangle. So I can't identify its type, I just simply say it's not one. Now, the example that we didn't show, the one that we didn't show an example of, is how to see that a triangle is acute. But what you're going to see is just a less than symbol here between your a squared, and c squared is going to be less than a squared plus b squared. So that completes our notes on how to determine what type of triangle will be created given 3 side lengths, or if any triangle is even possible.